The R-group clipping tool enables chemical building blocks to be easily transformed into the corresponding substituents for enumeration of virtual libraries using StarDrop's Nova module. In this example, we will use a set of commercially available secondary amine building blocks downloaded from eMolecules to explore a virtual library based on replacement of the substituted isoindole in the co-crystallized ligand shown on the left. Using the R-group clipping tool, available under R-groups on the Tools menu, we can define the site of substitution using a very flexible substructure search editor. In this example, we would like to consider only cyclic secondary amines, so we can define that the adjacent bonds must be within a ring. We would also like to ensure that the adjacent carbons are sp3, so we will apply the constraint that they must have 4 bonds. Having specified the site of substitution, we can choose the bond to break to define the connection point, in this case the bond between the nitrogen and hydrogen. We will also exclude the hydrogen from the fragments that will be generated by the clipping. It is possible that the substitution site will match multiple positions on the same molecule, and we can choose how to treat these cases. In this case, we will choose not to generate any fragments to avoid the potential for interference in the reaction. On clicking OK, the fragments are generated by clipping the building blocks where the substitution site is found. Here you can see that there are 2 examples where the search constraints do not match, and therefore a fragment was not generated. Once created, the fragments can be immediately used to enumerate a virtual library using StarDrop's Nova module. Here we will use the compound from the crystal structure as the basis for the library enumeration. For more information on the Nova module and library enumeration, please see the demo videos and tutorials on Optibrium's online community. Having defined the substitution point on the resorcilic acid core, the fragments generated by the R-group clipping tool in the secondary amines dataset can be selected and the resulting library generated. The metadata associated with each substituent is copied into the virtual library and associated with a corresponding compound, making it easy to order the building blocks for synthesis of the highest priority compounds. Returning to the secondary amines dataset, the fragments generated by the R-group clipping tool can be added to the fragment library in StarDrop for easy access and reuse in the future. Fragment libraries can be easily managed, shared between users, or stored centrally for access by all StarDrop users. If you have any questions, please feel free to contact us at stardropsupport@optibrium.com.